The graph of the cosine function is very similar to the graph of the sine function. Once again, we will be putting in to the function angle measures in radians, and we will take the cosine value of those angles, and then the output will be the cosine value at those angles. So here we have our x values, these are angles measured in radians, and then out comes the cosine value, or the cosine ratio, at those angles. Let's take a peek at our unit circle again. So we know that on the unit circle that the x value of each of these points represents the cosine value of that angle. So as we go through, we pick off all of the x values for each of those angles. In quadrant 1, we can see that the cosine ratios are positive, and then cosine is negative in quadrant 2, negative in quadrant 3, and then positive in quadrant 4. So these are where the values are coming from, all those x values for each of those angles on the unit circle. And let's look back to our animation for where that shape comes from. So we're starting here at 0 radians, and then as we go through quadrant 1, cosine is positive, and notice that little green bar there represents the x distance, or the x value, and notice that it's getting shorter. Those x values are getting smaller, they're decreasing throughout quadrant 1, but everything's still positive. So you notice that the graph here from 0 to pi over 2 is above the x-axis, but decreasing, and we stop at a cosine value of 0 there at pi over 2. And then as we go through quadrant 2, notice that we're in the negative x direction, so cosine is negative, and the graph starts to dip below the x-axis there. And then as we come into quadrant 3, once again cosine is negative. And we're still below the x-axis there from pi to 3 pi over 2. Went a little too far there. And then the last quadrant, notice that we're starting to come up again above the x-axis, and that is because we are in quadrant 4. And notice that the cosine values, those x values are increasing and also are positive in quadrant 4. So that's one complete cycle of cosine, one time around the circle from 0 to 2 pi radians. And notice that the gray part of the graph looks exactly the same as from 0 to 2 pi. So from 2 pi to 4 pi, or another time around the circle, we see that we start to pick up those same exact x values every time we go around the circle. So for all these coterminal angles, we're getting exactly the same cosine values every single time that we go around the circle. So cosine is a periodic function. It repeats itself every 2 pi units. Let's go back to our notes here. So we want to keep track once again of just the quadrantal angles. We have 5 key points again. Let's actually graph them. So if we have 0 angles, or 0 radians for our angle, the cosine value of that is 1. So remember that the y values are the cosine values of the angles, or those cosine ratios, and the x-axis is labeled with angles in radians. That's our input. If we look at pi over 2, the cosine value of pi over 2 is 0. At pi, the cosine value there at that point is minus 1. 3 pi over 2, the cosine value is 0 at that angle. And then for 2 pi, the cosine value, as we come back to the starting point on our circle, is 1. So 2 pi comma 1. So here's our one cycle of cosine. And we want to be familiar with these 5 key points on the graph. And notice once again that if you look at those 5 quadrantal angles from 0 to 2 pi, that each one of those is equally spaced apart. This represents quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And each one of those segments has an equal distance or an equal width of pi over 2 units, or think about them as 90 degrees for each one of those quadrants. But they're equally spaced apart, and that's going to be once again important when we start talking about those 5 key points later on, that they're equally spaced throughout cosine. Alright, so let's look at the summary here of cosine. When we look at the graph of y equals cosine x, we notice that it has a domain of all real numbers. In other words, any angle in radians that I wish to put into the function will work and be fine, give us a good value for cosine. The range goes from -1 to 1, just like sine. The minimum value that we reach for cosine is -1, the maximum value, +1. Repeats itself every 2 pi units, so the required horizontal distance to complete one full cycle, 2 pi units. So that's the period for cosine. And the amplitude, once again, is +1. When we look at the graph, from the middle of the graph, or from the x-axis to the maximum values, we have two spots on the cosine function that go from the middle to the maximum values here. That's 1 unit long. So that's the vertical distance from the middle to the top of the graph, from the middle to the max. From the middle of the graph to the minimum value, so from the x-axis here at pi, when I go all the way down to that minimum value, that is also a distance of 1. So we would say that the amplitude of our cosine function is 1. The graph of cosine is symmetric with respect to the y-axis. In other words, if I fold it in half along the y-axis, then the graph would coincide with itself. And that's what we would call in college algebra an even function. And by definition of an even function from college algebra, if there is a negative angle on the input, it is exactly the same as taking cosine value of the positive angle. So these two graphs would be equivalent.